Hello, my name is Bert Woods. I'm an applications chemist here at Agilent Technologies in Wilmington, Delaware.
And I'm Amir Liba, an application specialist at Agilent Technologies. Today we're going to be discussing the Agilent ICP Triple Quad, the first ICP MS with MS technologies. And I will be talking about the hardware.
And I will be talking about the Mass Hunter software part of the instrumentation.
The unique and absolute phenomenal capability of the Agilent 8800 ICP Triple Quad really comes through with its MS technology. Samples are typically in an auto sampler, which go through the samples they're taking for analysis. We are using a 3-position peristaltic pump. The first position is for the sample uptake. The second position is for the internal standard, while the third position is for evacuation of the actual waste. The sample is then carried through a nebulizer. This is a concentric nebulizer, low-flow concentric nebulizer, which nebulizes the sample into a Scott double pass spray chamber. The small droplets then are going to be carried into the torch and eventually ionized in the plasma. I will now open the latch to show a closer look at the inside of the sample introduction. And right up front, we can see that we have the high matrix interface that would allow you to do aerosol dilutions, which is a high capability of any of the Agilent ICP MSs. We are then looking at the torch, and we see the two gases. One is the plasma gas and the auxiliary gas. Fairly simple, all really easy to dismount and mount back. And we're going to push this little button right here to allow the entire sample introduction to move back so we can access the cones and the lenses, both of which are outside the high vacuum, so you never have to break vacuum in order to access cones or lenses. The sampling cone is being held simply by a retainer ring, which is handy mounted, and then the cone literally comes out in one piece. And what you can see back here is basically the skimmer cone, which is mounted onto the lens base. After the sample gets ionized, these ions then obviously are getting carried into the high vacuum region, where in the Agilent 8800 Triple Quad, we have a Quadrupole, the Octupole reaction system, then the second Octupole, hence allowing for MS capabilities.
So now I'm going to take you through the Agilent 8800 Mass Hunter software. For this, we will go through the ICP MS instrument control icon. From here, we can cut the plasma on and go through the startup protocol of the Agilent 8800. The startup protocol has several parameters that the instrument will do for its tuning function. Those parameters are the torch axis, which is the horizontal and vertical torch positions, the EM, which is the electron multiplier detector, the plasma correction, or HMI correction, the lenses, the resolution axis, or peak shape, performance report on the Agilent 8800 factory specs, full spectrum, so you can analyze on startup a sample, and pulse analog factor, which keeps your linearity over 9 orders of magnitude. So now we will turn the plasma on and go through the startup protocol. The first option is the torch axis position, which is the horizontal and vertical torch positions. In the startup, we're analyzing mass 7, mass 89, and mass 205 for our best torch position and highest sensitivity. So as you can see, the startup protocol has succeeded for all the parameters that we had selected. Now we can develop our method and run our samples. And this is done through the batch. In the batch, we can select whatever mass we want to use or whatever mass shift we would like to do, depending on the type of analysis we're doing today. In today's case, we're going to look at arsenic. Arsenic is monoisotopic, which means it has one isotope, mass 75. To select a mass, we can just go to the periodic table here and left-click arsenic, and the default mass comes up. To remove a mass, we right-click. Today, however, we're also running some of the interferences that go along with arsenic. Arsenic has an interference with HCl. The interference is argon chloride. We're using liters of argon, and we're going to have chloride that we're spiking into our samples, about 3%. We're also spiking in some high REE samples, neodymium and samarium. They have masses of 150, among others. But that mass of 150 can be an interference at mass 75 by a double charged ratio. So I have spiked 10 ppm samarium and neodymium into the samples to show the removal of that interference. We're going to run this analysis in no gas mode. So in other words, where we are not removing these interferences. And then we're going to run in oxygen mode and do a mass shift from 75 to 91 and look at arsenic oxide, which will thus remove that interference. So now we're going to add to Q, which starts our analysis. Once we do that, the ICP triple quad data analysis window opens, which stores all our data and populates real time with the analysis that we're doing. So our analysis has completed, and everything populates into the Mass Hunter data analysis window. We have our internal standard graph. We also have options to look at QCs if you have done them, or you can go into spectrum mode to view your spectrum real time. So let's take a look at our data. We did our calibration for 75 arsenic in no gas and 75 mass shift to 91 in oxygen mode. In 75 no gas, which we calibrated in 0.5% HCl, we have a detection limit of only 40 ppt with a BEC, or background equivalent concentration, of 1.4 ppb. In the 75 mass shift to 91 mode, we have a detection limit of 2 parts per trillion and 800 ppq BEC. So now let's go and look at our data. So for 1% HCl in no gas, we get about 0.7 ppb showing up at mass 75. However, in the mass shift mode, in only 1% HCl, we don't see any detectable arsenic. When we go to 3% HCl, the 75 arsenic no gas gives us about 3 to 4 ppb, while in the mass shift mode from 75 to 91, we get 1 part per trillion. Now the more interesting modes. In 1% HCl with 10 ppb neodymium and samarium, or REE, we get about 200 ppb arsenic in no gas mode. However, in the mass shift mode from 75 to 91, we get about 80 ppt. In the same sample, but 3% HCl with 10 ppm neodymium and samarium, again we get about 100 ppb arsenic in the no gas mode. However, we get the exact same amount, 84 ppt, in the 75 to 91 oxygen mass shift mode. Next, we've spiked this sample with 10 ppb arsenic. In the 75 no gas modes, we don't see a real good correlation because of the interference that's being created by neodymium and samarium. In the 75-91 oxygen mass shift mode, we get great correlation with 10 ppb recovery on both samples. And lastly, we've taken the 3% HCl with the 10 ppm neodymium and samarium, along with our 10 ppb arsenic spike, and also spiked with 1 ppm zirconium. As you can imagine, the 75 mass no gas of arsenic doesn't show the addition of zirconium because zirconium's primary isotope is 90 and 91. However, in our oxygen mass shift mode from arsenic to 91, we get great correlation, just as we had before there was any arsenic in the sample, of 10 ppb arsenic. Thank you for your time in reviewing the 8800 Agilent triple quad ICP MS. We hope you enjoyed the enormous capabilities that MS technology that the 8800 provides.
And for more information, please visit us at chem.agilent.com.